We've looked at how we can use factoring to solve a quadratic equation. We can also solve some quadratic equations using square roots. We can do this if we don't have an x term, meaning the problem has an x squared in it, that's what makes it quadratic, and then a constant. So here's how solving with square roots work. Again, notice in our directions we're asked to give exact answers, no decimals are going to be allowed. So we'll have to use our simplifying tricks from some previous lessons. So basically you're going to solve this as you'd solve any linear equation. So people would look at this and students tell me, well, oh, just add 5 to both sides. And that's absolutely what we're going to do. I'm going to add 5 to both sides. I'm just solving this like a normal equation until I get to the normal linear equation until I get to the end of the problem. So at this point, divide both sides by 2. And I get x squared equals 100. Now at this point, here's where my new step is. I don't have x by itself, I have x squared. So to undo squaring something, I'm going to take the square root of both sides. The square root of x squared is just x, and the square root of 100 is just 10. 100 is a perfect square. Otherwise, I would need to do a factor tree to simplify that square root and not get a decimal. So my answer is 10. You may recall, though, from solving by factoring, there were 2 answers because there were usually 2 x-intercepts. And it turns out there'll always be 2 answers. So the reason 10 is the solution is we said, well, we need a number that multiplies by itself to equal 100. Like that's what this says, x squared equals 100. So 10 works because 10 times 10 is 100. But there's a second solution as well. There's another number that multiplied by itself will also get you 100. And that number is negative 10. Negative 10 times negative 10 is also positive 100. So when we're solving with square roots, there's a positive and there's a negative version of our answer. So that's a big thing people forget about, that plus or minus sign. But make sure you have that on your solutions. There's always going to be 2 when we're solving with square roots. So there's a positive and a negative 10, both as solutions. Okay, let's try one more, unless you want to try this on your own and pause the video. I'm going to subtract 5 from both sides, so I'll get 3x squared is equal to 36. Dividing both sides by 3 gets me x squared equals 12. And at this point now is when I want to take a square root to finish the problem. So the square root of x squared is just x. 12 is not a perfect square, so I do not want to get a decimal for it. Nor do I want to put down square root of 12 because I always want to check for ways to simplify. So 12 could break down into 4 times 3. Remember doing the factor trees, and then 4 breaks down to 2 times 2. So I'm looking for pairs. Any pairs of numbers get to go out front, and any single numbers were left over on the inside. So this problem simplifies to 2 times the square root of 3. Now remember though, there are 2 answers. One solution is positive 2 times the square root of 3, but we do have the negative version of that as well for my 2 answers, so don't forget that plus or minus sign. We can also use square roots to solve problems that are written in vertex form. Hopefully you remember vertex form back from when we graphed. It was when we had our set of parentheses squared. The biggest piece of advice that I can say is do not expand these. Do not work these problems out. Do not do, like, for example, z plus 3 times z plus 3. Don't try to do that. You're going to make the problem so much more difficult. In fact, you're going to make it impossible to solve with square roots. So leave it the way it is. I'll show you how we're going to deal with it. So basically, pretend what's in parentheses is just your variable. So pretend this problem just says 2z squared minus 3 equals 7. Just pretend that's all it is. And do what we did on the previous page. So start with adding 3 to both sides. So we get 10. Now at this point I have that 2 in front, but remember we're just pretending it's 2 times z squared, so I'm going to divide both sides by 2. Some people want to try distributing the 2 in. That's not allowed. Exponents come before multiplication, so I'm not allowed to distribute that 2 in. So the best I'll do is I'll just divide by 2 to cancel that out. So now I have z plus 3 squared is equal to 5. At this point, there's nothing else I can do because I do not want to. I don't want to multiply that out. I don't want to do z plus 3 times z plus 3. It's going to make the problem impossible to solve with square roots. So instead, what I'll do is the only way to undo squaring something is to square root. So I'll take the square root as my second to last step in these problems. So squaring a square root cancels that out. All that's left is z plus 3, and I'll drop the parentheses at this point. The square root of 5 is irrational, so I don't want decimals. 5 can't be simplified. There's no factors besides 5 and 1, so I just get the square root of 5. But remember, I have a plus or minus version of that answer. As soon as you take the square root, put your plus or minus sign down. Now I'm trying to get z by itself, so I have one extra step in these problems, and that is to get rid of the positive 3. So I'll do that by subtracting 3 from both sides. Now the best way to write your answers I found is write that number down first. So the 3 that I subtracted, I'll put that down in front. so -3, and then after that I'll put plus or minus the square root of 5. So our answers start to look a bit unusual, but that's how they're going to look for some of these. That's as simplified as my answer can get without using decimals. Now what I want to do with this one as well, real quick, before we finish our last example, is I want to write the two solutions down. Some people think the solutions are one solution's -3 and one solution's square root of 5. That's not the case. The two solutions that we got, one solution is -3 plus the square root of 5. Whatever that decimal would be if I worked it on my calculator is one solution. The other answer is -3 minus the square root of 5, whatever decimal that is. So just to be clear, those are the two separate solutions. Okay, let's try one more of these and we'll finish with our story problem example, our application. So like last time, start by adding 10 to both sides. I never ever want to multiply out that exponent or do the exponent part of the problem. So I have 25 on the other side. There's nothing to divide out in front, so at this point I'll just take the square root of both sides. Squaring a square root cancels it out, and I'll drop the parentheses, so I have x minus 1. 25 is a perfect square, so the square root of 25 is just a regular 5 without a square root. Keep in mind though, there are still two answers. As soon as you take that square root, there's the +5 answer and there's the -5 answer, okay? And like last time, I still need to get x alone, so I'm going to add the 1 to the other side, so I'll write that number down in front, +1. Then write down your plus or minus part. Now last time we stopped because there wasn't anything we could do last time. There was a square root in the problem, so I couldn't do anything else with it. This time though, there's no square root, so I should be able to simplify this even further. It's two problems in one. One problem is saying do 1 plus 5. 1 plus 5 gets me 6 as an answer, so there's one of my solutions. Not plus or minus 6, just 6. The other problem is saying do 1 minus 5. So 1 minus 5 gets me -4. And again, the reason I could do that this time and get two unique answers like that was because I had no more square root. And some people think, well, why did I get two answers this time but only one answer last time? Remember, last time we did have two solutions. That's why I wanted to write them down separately. So no matter what, we're still getting two solutions. For our application problem, we're going to work with gravity. Anytime something is dropped, the only thing pulling it towards the ground, the only thing that's affecting how fast it falls, is gravity. It doesn't matter how heavy the object is, as long as we forget about wind resistance and stuff like that. So if we want to figure out how long it takes something to hit the ground, all I need to know is how high we're dropping that object from. So in this case, we're dropping an anvil from a height of 50 feet. So here's the equation we're going to be using. It comes from physics, so if you're not in physics, don't worry too much about where it comes from. You can deal with that in physics. For our purposes, all we need to know is what our variables represent. The h over here represents our final height of the object. So in this case, we want the object to hit the ground. Well, the Roadrunner doesn't want it to hit the ground, at least not on him. So my final height's going to be 0 because I want that to be on the ground. -16 comes from gravity, and it's, again, don't worry if you haven't studied physics. You may be used to -32 if you've been using meters. -16 is the feet version of that. T is time, so time squared. And then the h sub o represents our initial height of the object, so 50. So the only variable we have to plug in for is our final height and our starting height. And then since there's no t term, just t squared, I can solve this using square roots. So I'm going to go ahead and subtract 50 from both sides of my equation. So -50 is equal to -16t squared. Now don't be worried about all the negatives that you see. You may be worried just because you're thinking square roots and negatives, they don't mix. But I can go ahead, or as soon as I go ahead and divide by -16, all my negatives will go away. So -50 divided by -16 is 3.125, and then equal to t squared. Now story problems are the one exception to the no decimals rule. In this case, I do want decimals. In a real life problem, I'm just concerned about an answer. I don't want to know that I have square root of 5 seconds before an anvil hits my head. I just want to know how many seconds do I have. So we're going to be okay to round in these story problem examples to 2 decimal places. So to finish this one, I'm going to get out my calculator and I'm going to take the square root of 3.125, and I'm going to get an answer of approximately 1.77 seconds. So I have a little under 2 seconds to get out of the way of that anvil. Now, we'd said there's always two answers, and that's true in a math problem. In this case, though, in a real-life application, there's no such thing as negative time, so I do just have my one positive solution of 1.77.